Hello everyone, and welcome to today's PV Tech Talk webinar with Rated Power. And we'll be learning today about software to help developers design and optimize their solar PV projects. I'm Andy Colthorpe, Deputy Editor-in-Chief at Solar Media, and I will be moderating today's session. Now, roughly 80% of PV projects that are in the queue never make it to commercial operation for a wide variety of reasons. Developers, EPCs, and PV engineers face many challenges when planning and designing utility-scale photovoltaic plants. Permitting and regulation, as well as increased materials costs, make it more challenging and time-consuming for renewable energy professionals to complete the design and engineering process efficiently and quickly. The ability to digitally design PV projects does exactly that, make it quicker and more efficient. And it is an important part of minimizing the work needed at the initial stages of a project. Software like RatedPower's cloud-based solution, PV Design, can improve the end-to-end engineering process and speed up the development time. And it does this through automation and making it easier to change design parameters to fit planning regulations or grid constraints, and compare designs with different inputs in order to achieve the optimal configuration. PV Design optimizes the design and carries out the engineering of utility-scale solar PV plants, and potentially reducing design time by up to 85%, while clients have reported a 5% decrease in the levelized cost of energy of solar plants using PV Design, which ultimately translates to a 20% higher profitability per plant. So I'll leave it to Rated Power to explain that to you more in terms of the technology and the value proposition and how it works. And so they will be presenting their software and showing you how you can reduce that time invested and maximize that final return. We will also be hearing about a design success story in the UK and how automation and digitalization tools can help overcome the challenges of managing increasing penetration of renewable energy onto the grid. So although PV Design has in fact been available since 2017, the solar sector has grown rapidly in recent years with more projects than ever in development. And the company's client list include names like Bavar RE, Siemens Energy, Tata Power, NextEra Energy, Lightsource BP, and today's guest, Bute Energy. And with long development times and grid issues affecting solar site development in the UK, it's more important than ever that companies building PV power plants do manage to reduce those development costs from as early as possible in the development cycle. So as I mentioned, joining us for this webinar is Rated Power client Bute Energy. Just to give you a few words on Bute Energy and why they're with us, Bute Energy is driving the shift to a decarbonised energy system across Wales, creating a family of energy parks that generate clean, green power and at the same time bring critical economic growth to communities. Bute would describe itself as privately owned for public good. And I've been told the vision Bute Energy has for Wales's future is to make sure that Wales is a thriving, healthy, wealthy nation, independently powered by renewable energy, which is sustainable and, of course, decarbonizing. And the mission is to deliver on this promise by creating renewable energy projects that provide clean, affordable power while fostering local economic growth and social well-being. And in fact, parks such as that across Wales can deliver 25% of the green energy that Wales's government says is needed to achieve net zero, and playing a pivotal role in meeting their government's target for 100% renewable electricity in Wales by 2035. So today's speakers are Carlos Sanchez-Smith, who is a senior energy analyst at Bute Energy. And from Rated Power, we have Faten Driss, who is a technical advisor, and Gonzalo de Blas, who is the account executive for UK and Ireland, again with Rated Power. And as always, Interaction with you, our audience, is very important to us. So please do put your questions for today's speakers in the questions tab that you can see on the right-hand side of your screen. I cannot promise that we'll be able to answer all of your questions, but we will do our best to take on as many as we can. And also moving on from that, I'm sure that Rated Power and probably Bute Energy would be more than happy to follow up and continue discussions and get your questions answered offline following this session. So with that, and without further ado, I'll hand over to our first speaker, Gonzalo, who will be beginning with a presentation on Rated Power's work and how the software works.
Thank you very much for the introduction, Andy. My name is Gonzalo de Blas. I work as an account executive at Rated Power, focusing on the UK and Irish markets. Been doing this for almost 3 years now. And just before I start, I wanted to give you, Phaeton and Carlos, a chance to say a few words about yourselves.
Thank you, Gonzalo. So I present myself. I'm Phaeton Dries, a technical advisor at Rated Power. I'm also a renewable energy engineer. So I'm responsible on the French market and also new markets in the world. And I hand over the presentation to Carlos.
Hello, everybody. Thank you, Phaeton. And thank you, everybody, for attending this webinar today. My name is Carlos Sanchez-Smith, and I work as a senior energy analyst at Bute Energy, mainly focusing on energy GL assessment for both wind and solar sites. And I hand over to Gonzalo, back to the presentation.
Great, thank you very much. Okay, so just to briefly go through the structure we're going to be following today. First, I'm going to introduce a little bit about Rated Power and our product and milestones. I won't delve too much into this, as Andy already gave a great presentation. And then I'm going to be talking about the challenges faced by our clients and different industry players globally, but also specifically in the UK. And finally, Carlos and Phaeton will be planning a PV project or case study on PV design software while tackling the challenges and constraints that we will touch upon in the presentation. So in a snapshot, at Rated Power, we want to accelerate the energy transition. For this, we have developed a cloud-based software, PV Design, which automates and optimizes PV plant design and engineering. This is across all stages. With PV Design, players in the utility scale ground mount solar market can make the design and engineering process shorter, simpler, and more automated. Not only that, but ultimately achieving better optimization and lowering power generation costs, as well as increasing profitability. Here you can see a picture of some of our customers. We currently have more than 300 customers worldwide, one of them being Bute Energy. We started working with them around a year ago, and we'd like to thank Bute generally, but also Carlos particularly for joining us today. Now, moving on to the challenges that our customers and other industry players are facing, we conducted a market research report earlier this year by taking into account market intelligence from experts as well as data from our software. The top five we identified were first grid saturation and instability, then we have permitting and regulation, an increase of costs, mostly equipment, also a lack or difficulty to find skilled personnel, and finally the issues or constraints of land availability. If you want to learn a bit more about this report, feel free to scan the QR code on the presentation. And then moving on to the UK specifically, these are the 3 points that we find are the biggest constraints in the UK currently for our clients, so UK-based PV players. We have first the issue of land classification and agriculture interaction, which has become a bit of a hot topic recently. Then we have the technical considerations of agri-PV, which is related also to other new technologies, which we're starting to see, such as battery energy storage systems in co-location with PV. And ultimately, there's the need for more optimized PV projects or PV designs from the very early stage, and not including only the PV itself, but also interconnection, such as, for example, the substation. Now, these two last points will be discussed quite in depth by Phaeton and Carlos later, using PV design software, whose main value proposal is to do with optimization. But the very first step before starting a PV project would be the site origination. So I want to discuss a bit more in depth what this land classification agriculture has to do with all of this. So I wanted to explain briefly these challenges in the UK with land classification. So in the UK, land is designated within the ACL scheme, or agricultural land classification. There are different grades, so it goes from 1 to 5. 1 being the best possible land for agriculture, 5 being the worst. Okay, so you have subgrades. You have 3A and 3B. Basically, the land comprised between grade 1 and 3A is designated as best and most versatile land, or BMV, and this is reserved for farming. Okay, as it's the highest quality land that can be used for this purpose. Now, the development of PV or any other purpose on this sort of land is highly discouraged, and it's quite unlikely to get approval for this. However, most solar farms in the UK are currently installed on land that is designated as 3B. So it's the immediately next grade. Why is this? Mainly because grade 4 and 5 is less suitable. It tends to be highland areas, maybe that they don't have enough flat ground, and the soil is not good enough to install solar panels. Also, they tend to be located far away from access to the electricity grid, so interconnection possibilities are not great either. Now, recently, it's been a bit of a hot topic because the government had been exploring plans to expand the scope of BMV to include also the 3B category in order to enhance food security. This recently seems to have been ruled out, which is good news for the PV players, but still it's an issue to pay attention to. If this had gone through, the proposal to extend this to 3B would effectively prohibit solar farms from being constructed on 41% of the land in England and around 58% of the UK's agricultural land. Okay. By contrast, if all the solar farms that have been proposed were built, they would account for less than 0.4% of the UK's farming land and 0.28% of its total land area. Now, why am I talking about this? So before making a PV project, which we'll be saying how to do now, when securing land, taking into account these constraints in terms of land classification is really key. Once we've identified a viable piece of land, a plot of land, we can use PV design to optimize its use. But there is also another case scenario, which can be once we've started to design a project, we might realize that part of the plot we're using is 3A, and we might need to make some readjustments. And we want to be able to do this as quickly and precisely as possible. This is one of the things that Phaeton and Carlos will be touching upon in a minute, where they will create a sample project on PV design software for optimization, focusing on the results and KPIs while debating different configurations. So Carlos, Phaeton, take it away.
Thank you, Gonzalo, for this presentation. So I will be sharing my screen to showcase our software. And we can discuss the project that we have created with Carlos from now on. So as you can see here, we are inside PV design. So here we have the designs page inside our project. So what we did with Carlos, we created a project in Birmingham in the UK, and we tried to have various configuration, various designs to compare them. But before starting to talk about the comparison, I'm just going to show a small presentation for our software. So as you can see, PV Design is a cloud-based software. You have different tabs here that we can go through, but mainly for this presentation, we will stick to the projects. It is also a collaborative tool, so you have a limited number of users. So for this project, let's start first by starting a new design. I want to mention, like here for our client, the one that are used with, to PV design, we just launched this new interface that can help you to edit a specific design without going back and forth, cloning and design, generating at the same time. So you can edit for one design here, and you will have your designs in the history of designs in this section. So this is a new update that we have. Each time we are launching new options. So as Gonzalo said about the land classification for the UK, here inside your design process, you have the site, and which is the most important step in our project creation, which is the creation of the site. So Here you have two options. You can either upload your site directly from KML or KMZ format if you are working with Google Earth, but also you can create a site from scratch inside our map box here. So we have also another option in case that you have a change of mind, or you have more constraints about your different available area. You can clone your design and make the changes throughout the process of creating a project. So we don't give you we don't give you any constraints. You have the liberty to each time clone, change, and create other designs. So here we are inside the site creation. We have different options. You can create your available area, restricted area. This is also one new option that we just launched, to have different shapes. To when you design your site, you can design it as a free shape, as a polygon, rectangle, or circle. So we have four main elements that you need to define, which is the available area, AC point, access point, the substation, and the MV point. But also we have other options in case that you are working with batteries. You can define your battery area. You can also use the overhead line to connect your project to the grid. So once you have finished the creation of your site, you have to save the site as a new site. So once the site is created and the location is selected by the user, PV Design gives you flexibilities in terms of topography and meteo data. We give you Google Earth as a source, PVGIS also for the meteo data, but of course we give our users the flexibility to upload their own file for the topography and meteo data. We have here in this section the different tabs that you can go through, but you are not obliged. But the main part is the site creation. So you can here define the different equipment that you will be using in your project. And we offer to our user a large public database, which is updated once a year. But also you have the possibility to upload your own PAN file and your own ONT file and create your own structures directly inside PV Design. So it is the same for the inverter and the other equipment that needs to be configured by the user, depending on the specification that you have. So also you can see you are not constrained to have only one available area. You can have up to 30 available area inside your site here. We have also this option in the layout tab where you can decide the capacity of your project, the energy requirement. You can either specify your power requirement here by defining, for example, the number of inverter, but also we give you the option to have the maximum peak power based on the available area that you have here. We have also different configuration. I want to mention that PV Design give you recommended values, but also we give you the flexibility to customize these values. For example, pitch distance, we have recommended values, the GCR clearance distance. Also for the roads configuration, we give you automatic roads configuration, but you can, from the site creation, introduce your own roads. So as you can see here, we give a lot of options that you can change, dimensions, distances, setbacks, and we also tackle other subjects like the topography. You can consider here the analysis of your terrain, the analysis of your topography file that you introduce to discard some structures, install some structures, and also we give you the grid point to have the connection of the project to the grid. You can select some standards. Here you can have all the configuration that you can change more in detail, but also you can keep these parameters unchanged in case that you don't have any further details. it is the same for cables. We tackle also this option to define the cross-section per subsystem of your project. And for batteries, we have a specific area for the batteries. For now, we are using the AC coupled batteries, but on our roadmap, we are going also to introduce the DC coupled batteries. So here are in the energy tab, you can define some losses. And one of the important tab that we will also tackle during the discussion with Carlos will be the cost tab, where you can either use the CapEx sheet provided from IRENA as a source, but also you can configure it as you need based on the value that you have. So to go back, so this is a small introduction to PV design, but for this presentation, what we did with Carlos, we tried to have a comparison between different configuration. So the first one we created will be a fixed bifacial configuration. So let's clone this specific design and see the different parameter that we changed. So we have a project that is typically in the UK. So after creating the site, we went to the selection of the PV model. Here you can see in the type, we selected a bifacial one. You can now go to the layout section where you can change the configuration here. So Carlos, for this, can you explain more the reasoning behind selecting these values of the DC-AC ratio for this specific configuration?
Yes, of course, Peyton. So what I normally do is consider between 1.05 and 1.15 on DC-AC ratio when using bifacial panels. It is true that on monofacial designs, this can be adjusted up to 1.4, but I think that for bifacial, the extra energy generated from the backside of the panels could lead to increased clipping during peak load hours, especially during summer. So a good tool that the software gives you to optimize this solar plant using different DC-AC ratios. Well, we'll see it later on the pitch optimization and tilt optimization, but you can also do on DC-AC ratio, and you can find that for bifacial panels, like the better value normally is between 1.05 and 1.15. Yeah.
Okay, thank you. So what you were referring to, so that we can explain, it is this option to run a batch of designs. You have multiple designs. You can vary various configuration. And for the specific parameter, you can change the DC-AC ratio by introducing the minimum and the maximum value with the step value. And you can generate these designs and compare them. And after came up with the Carlos came up with the specific values for this configuration, right?
Yeah, exactly. Thank you, Peyton.
Okay. So apart from the DC-AC ratio that we change, we also change the pitch distance. As you can see here, PV Design give you recommended values, but why do you usually use the pitch distance as 12 or 12.5?
Yes, so I normally use a pitch distance of 12 or 12.5 because that leaves a ground coverage ratio of around 33%, which I think it is quite industry standard. And although higher pitch would reduce shades between the panels, it would improve energy output, but it would also incur into higher trenching and cabling costs. And this will reduce significantly the levelized cost of energy. So by using PV Design, I have been able to test different configurations, and because you can change the CapEx templates, you can input there the cabling and trenching cost. And what I found is that optimum values of pitch are around 12 and 12.5 for bifacial panels.
Okay, thank you for this explanation. But also another value that we changed was the minimum ground clearance here for the mounting system. So you usually take it 0.8, also this factor.
Yes. So normally, well, it's been proved that by increasing the height at which the modules are mounted directly, it increases the amount of incident backside radiations on the bifacial panels. So this basically allows reflected light from a larger surface area to reach the back of the module. And for fixed structures, with the aim of reducing cost and increasing efficiency, I've tested that 0.8 is quite optimal in terms of levelized cost of energy. So we are increasing the energy that the panels produces and also having a really good levelized cost of energy.
Okay, so thank you. And as you can see here, you can change parameters at the same time and run the design. You will have it here. What can help you in this comparison? We have the comparison tool. So you can, we will take the example of the bifacial, fixed, and monofacial. So for the monofacial, we just changed the type of PV model, and you can select both of these designs and compare them. So PV design in the comparison tool allows you to have this data table as a first result. You can also add the some of the filters that we have here in case that you want to base your comparison on different parameters, so you can introduce them there. But also this comparison can be seen in charts, and everything that you can see here can be exported in Excel files. So we can see here that for the monofacial and bifacial, we have this comparison, and based on the value of the LCOE, also PV design, when it highlights this value, it means that this is the best design for this comparison. So you can see here we have a lower LCOE for the fixed bifacial, and this is the best design for this comparison.
Sorry, Peyton, I don't know if you have this, but I cannot see the comparison on the screen right now. I just see the design on the screen. I don't know if it's me or...
Okay. Here you can see, right?
Oh yeah, I can see it now. Sorry.
Okay, perfect. So what I was showing, it was the comparison in data table here. So you can see the values for the filters that I showed earlier are in this section, and also the comparison can be seen in charts by clicking on this section. So for the this comparison, you can see the highlighted value. So for the bifacial, we have more energy generated. Specific production is better than the monofacial, and also based on the LCOE, we can see here we have the best value comparing these two configurations. What comparison also we did with Carlos, we tried to introduce the Agri-PV, which is an important subject that we will tackle here. We selected the tracker structures, and we introduced the clearance distance with higher value. So let's select this and clone this specific design, which is a tracker 1P bifacial, and we change the minimum ground clearance. So you can see here directly inside the design process, you can change simply by clicking on tracker and selecting the type of structure here. And in the mounting system, you will have the minimum ground clearance parameter that is changed. So Carlos, can you explain the reasoning behind selecting this specific value for the Agri-PV projects?
Yes. So what we are trying is to combine PV with agrivoltaics, and by agrivoltaics I mean that introducing animals in the solar farms as well. So we are worried that the animals can chew the cables and jump into the panels. So the idea is to raise this minimum ground clearance to 1.2 meters, which is already quite a lot. From an engineering perspective, I would say, as I said before, that 1.2 meters is quite challenging, and as we will face higher wind loads, and therefore the structural cost will be higher, and this will have an impact on the levelized cost of energy. So yeah, it's true that by raising the panels, we will get a higher energy output as well that can be a little bit compensated. So that's the reasoning behind this value of 1.2 meters.
Okay, that's great. Thank you. So also we change for this. You change your specific value here. You don't use IRENA. You use this option. So do you think this option is helpful to customize your own CapEx sheet inside PV
Yes.
design?
So exactly, when you're comparing different options, you need to take into account that you'll have different pricing for different types of structures, or even different type of modules or inverters. And it's very useful that you can use this CapEx sheet, basically getting prices from IRENA if you don't have direct prices from manufacturers. And you can combine even your own prices you have from manufacturers with the IRENA ones. But for this specific exercise, we've used a mix of IRENA prices and a specific cost for the structures. So it makes it very useful when comparing different levelized cost of energy and the different options.
Okay, that's great. So let's go back to the comparison here. So also one of the added value in PV design, it can help you to have an optimal value for example, the pitch, the tilt. So what we did with Carlos, we tried to have a comparison between different tilt angles. So to do this, you for the fixed, you need to clone the project, go back inside the design process here, and just click on the run batch. And for the tilt angles here, you can define the minimum value. So we define 20 as a value, and as a step tilt value, we define 2, and you can directly refresh the data table here. You will see the different designs that you have. We keep the pitch distance as fixed for this specific comparison. So you click on generate the design, and directly you will have the list here of different patch that is generated with different tilt angle. So before going outside the design process, I just wanted to mention, like for our new interface here, you can see from now on the overview, which is the results directly inside the design process, but also you can see the 3D view from here. So this can be helpful, and this result can be directly generated without saving the design and going outside the design process. So for this comparison, we will select the different patch and multiple design. You can deselect this one so that we have an accurate comparison, and click on compare. So we will take the tilt as a parameter of comparison here, and we can see based on the LCOE the best value, which is 30 degrees for this specific area, which is the value that Carlos is using, right?
Yeah, exactly. Well, it depends on the design and on the specific site, but normally I use 30 as a starting point, and then I use your optimizers to basically optimize our design according to the site.
Okay, so Carlos, can you give us a general comment about comparing these different designs that we have for the monofacial, bifacial, the trackers that we did. So, as an overall idea, what do you think?
So my opinion is that from the comparison of the different designs, if we focus on on the comparison between bifacial and monofacial panels, it can be seen that at the moment bifacial panels are much more attractive in terms of pricing, and this is because the past years the cost of bifacial panel is very similar to the monofacial ones. And there is a considerable energy uplift in case of this exercise. We have a 8% energy gain difference, which is a lot, and this is why we get much better levelized cost of energy on the designs. And then also moving to trackers, it's true that in the comparison we have here from a LCOE perspective, they are performing better, but I'd like to say that we have not introduced higher operational maintenance costs, which might make these options less attractive. And on agrivoltaics, despite the structure will be almost double from some of the cases, I think overall the levelized cost of energy is all right, and therefore we can start introducing this concept more often and hopefully have more solar plants in places that we were not able before. And I think, Phaeton, we have finished with the comparison on the software, so I give the floor now to Andy for the panel discussion.
Fantastic. Yeah, thank you so much, Phaeton and Carlos. I mean, it's great to see obviously to see the software and, you know, how it pulls in together all these different metrics in a pretty sophisticated way. And the way you demonstrated it, Phaeton, it looks pretty user friendly as well. And it's also great to have that sort of third party, let's say, customer perspective from Carlos. I just wonder privately if there are folks that you know, design solar power plants maybe many years ago that are wishing they had something like this in their hands. But that would be a little bit mean of me to say so. But it's really sophisticated industry now, isn't it? I think it just shows how much the industry is kind of maturing and bringing the technology on with it. Now, we do have lots of great questions from the audience, lots of them. So I feel like we should get through the questions that we have as well. So I'm going to exercise my editorial privilege and go first. Perhaps some of you in the audience might find your questions covered by the things we talk about now. But yeah, let's see where we get to with that. So, okay, Carlos, just wondering if you can give us an example. So Gonzalo talked as well about land classification issues. You know, outside of this, it's a topic, agricultural land has become a little bit politicized, but we're not here to talk about that today. Let's just say more in practical terms, are there any examples you can give us of projects that have been refused due to land classification issues, Carlos?
Yeah. I'd rather not give the name of the project, but there is a well-known project in Wales that was rejected because 36% of the site was located in land of grade 3A or above. So planning permission authorities said that the site would have a greater impact on this land, and therefore the project was rejected. So I'd like to say that this is why it is very important to focus efforts on deciding where your plant will be located. Although, as we've seen, the software is very useful at giving you different optioneering, let's say, on changing the shape of your plant and redoing the design. But this is a critical step on the design of the power plants.
Yeah, it's great to see just how much flexibility you can have, like in terms of that designing now. You know, it's really cool, I guess, if you pardon the street expression. So, you know, from a slightly more technical perspective, I guess, Phaeton, when you're looking at projects in the UK, yeah, what are some of the methodology, or how do you determine the optimal angle and tilt for PV panels, particularly considering the latitude and weather conditions, which can sometimes be a little bit changeable, I guess, let's say?
Yes, so thank you for the question. Regarding the optimal value for the tilt, it can be determined through the simulation and calculation based on the specific location, the latitude, climate, and also the energy goals of the project owner. But generally, the panels are tilted to an angle that allows the optimal sunlight to be captured throughout the year. So as I showed earlier, and I'm going to show it again now, in PV design, we help you to have this option by combining both of the comparison tool and the patch designs. So here, when you generate your random patch here, you can define the different tilt angles that can be changed, and based on this comparison, you can have the optimal value that you need. So just to showcase it now, how when you click on generate the design, you will have a list of designs here that have been are being calculated at the same time. You can see it doesn't take a lot of time to calculate like these designs, and once it's calculated and generated just by clicking on it, you can already see results in the preview, also in the overview section. And once you save your design by clicking on this, or you can also select the designs here, you save it and you go back outside just by clicking on small buttons here. You can already compare your designs and try to find the optimal value here. And as I mentioned earlier, you can have it also as an output document from the software.
Excellent. And yeah, one thing that I noticed that you mentioned earlier on was that it's a multi-user software that can be collaborative, and so you can have different designers on the same team as well, kind of comparing notes and sort of comparing their designs and stuff.
Exactly. So it's a collaborative tool. So you have a limited number of users per subscription, and everyone can open the different projects and can see the different configuration of each project owner, and you can design. Also, you have a limited number of designs, not only a limited number of users. So it can be useful for everyone using the software at the same time.
Wow. Okay. And yeah, and I mean, in terms of then assessing those different solar PV project designs, Carlos, I think as Phaeton said and Gonzalo said, there's a lot of different parameters, a lot of different data that go in. But yeah, so when you're making those assessments of different solar designs, what sort of parameters do you normally compare, Carlos?
I tend to look overall the specific production. I think is a really good one because it gives you an idea on how good your plant is compared to other designs. So you're using the same material file and you're comparing two designs that are different by using the same data. So basically it provides a direct comparison between your annual energy production and your installed capacity, and it tells you which plant is better, basically. And then another one we've been talking all the time, and it's very interesting looking at, is the levelized cost of energy, which gives you an indication on how much it costs to generate 1 megawatt hour of energy. So basically, the lower levelized cost of energy, the better the plant. And when you look at all the parameters together by assessing them, you'll be surprised sometimes that a larger solar plant is not better than a smaller one that can be much more efficient. So you need to find the sweet spot there to see what you want, what are the results you're looking for.
Okay, so yeah, a little bit of a balancing act involved there, I think, and just makes it pretty interesting, really, to even think about, and then to put that in practice is it's pretty awesome. So when we're looking at these optimized designs, Phaeton, how do these optimized designs compare to perhaps, let's say, a standard fixed tilt monocrystalline panel setup in terms of the installation and maintenance costs, really, I guess?
So regarding the optimized design, that includes the bifacial panels, single axis trackers. Typically, we have higher installation costs due to the advanced technology involved. Also, bifacial panels are more expensive than the monocrystalline panels, and also single axis trackers can have additional costs for the tracking mechanism. However, this optimized design generally offer more energy generation over time that can lead to a quicker return on investment and also higher overall revenue.
Okay, and to be honest, I think there's a few points you reached in that answer there that would love to go into further discussion of, but I think because we've got a lot of audience questions waiting, we'll just get these last two questions from me out of the way, and then we will go over to those audience questions. So thank you very much for that. And something we mentioned in the earlier presentation is agri-PV. It always seems a bit, maybe it's only journalists that care about this, but it seems like in the US, it's often referred to as agrivoltaics. In Europe, maybe it's more agri-PVs, lots of different ways of, but essentially it's ways of citing agriculture, solar PV harmoniously together, I think. And Carlos, I guess that must be something that you're looking into as well, clearly, something you talked about. But I understand that, as with some of the other technology options that Phaeton was talking about, there's an extra capex cost involved. Is the extra capex cost on agri-PV or agrivoltaics justified? And I don't know if you can maybe allude to some of the factors that kind of lead to that extra capex in your answer as well.
Yeah, of course. Yeah. So, I mean, it depends on what you mean by justified, but generally speaking, yes, I think it is. So for us, some areas would not be a possibility unless we can introduce this agri-PV, because as I mentioned, landowners want to have their animals grazing in their land, and I think it's a great idea to have this balance between animals grazing and solar production. So the problem is that from an engineering perspective, we would have to go high to leave minimum ground clearance, and we need to be careful on that, because it's true. I mean, the structures will be more expensive because we will need more material to raise the panel higher. But an interesting concept is that if you're using bifacial panels, the higher the ground clearance, the minimum clearance that we've been mentioning before, the more energy the system produces. So if you introduce all these concepts together, you'll have an increased bifacial increased production, and your levelized cost of energy impact will be lower by raising the panels much higher. So I think that the effect of raising higher the bifacial panels can balance the extra cost of the structures. And in some cases, if you directly compare a 2P tracker with a 1P tracker agrivoltaic, it would be more expensive, the agrivoltaics, but in some cases it would be a yes or a no-go to that land. So in my opinion, yes, it's justified.
Okay, sure. And ultimately with agri-PV and in fact, most forms of PV, there are kind of, let's say, benefits people assess that are, let's say, non-financial as well, but
Yeah.
Clearly the financial side is pretty important too, really important too. And on that kind of theme, Faten, if we're looking at the financial projections that you've calculated for PVs for the software, could you perhaps elaborate on how those financial projections were calculated using the IRENA pricing?
Yes, of course. So Basically, the financial projection is based on the IRENA, which is the International Renewable Energy Agency, benchmark prices for the solar energy. So this benchmark prices serves as a reference point for the calculating the revenue projection. So the energy yield estimates from each design were multiplied by the IRENA prices to estimate the annual revenue. It's important to know that the IRENA prices provide a standardized basis for the financial analysis, but actual market conditions and energy prices could influence project outcomes. So in what sense PV design can have an added value in this part is that first we first offer, based on the location of your project, directly IRENA as a first capex sheet, but also this capex sheet is updated once a year based on the values that IRENA generate, but also by clicking on this option and going to the capex sheets here, you will have in this section different public sheets that you can, and templates that you can clone, change, and create your own capex sheet based on this one. But also we give you the possibility to just create a capex model either from an existing sheet, but also you can create it from scratch. You have the option to add different, for example, categories, add entries, but the most important thing that you need to change will be the unit of your specific category or equipment that you are entering here. And based on this capex sheet, we will create directly a private sheet for you, and you can use it for your project.
Oh, okay. So it uses the IRENA projections, but you can tailor that somewhat.
Yes. So what we try to do in PV design, we give you recommended values, we give you standardized, for example, standards, documents, sources, but we give also the flexibility to the user so that he can change everything according to the type of details and according to the details that they have for the project. So that's why also we have the cloning option. So in case that you are inside the process and you need to change a specific parameter, you can clone your design or clone your site, change a parameter, and go back with the initial configuration that you entered.
Excellent. Well, yeah, thank you so much for your insights there. Okay, let's get some questions from the audience. This is not a specific question from one person, because I noticed that we actually had two members of the audience, I believe they'd be based in the US, asking if the Rated Power software and proposition is available in the US. And then we had someone from Brian from Kenya, who's asking, and I mentioned Brian because Kenya was talking about specifically for PV being embraced for agricultural activities. So Gonzalo, I don't know if this is one for you, but can you just tell us briefly, you mentioned all the clients that Rated Power has, and I assume that the involvement of folks like NextEra means that you are very much available in the US, but can you just tell us briefly about that and kind of how that is tailored to the different regions or not, or how's that working at the moment?
Mm-hmm. Sure. Happy to take that. Thank you, Andy. So we are a global software. It's cloud-based and it's used all around the world. We have clients on all continents, and there are some product adaptations that have been done for different regions. In the case of the US, it's actually where our mother company is based. So it is one of our fastest growing markets, and we do have some US specific features like NEC standard supports, and we also have cadastral data for the US in our site creation tool. So it is very much adapted to the US, but it's used globally, and we do adapt locally as well.
Okay, great. Well, yeah, appreciate that we're using kind of the UK as a case study here, but I mean, it's an important market too, I guess. So moving on, Vindra from the audience, thank you very much for your question, by the way, asks if rated power allows for forecasting generation needs for over 2 to 10 year timelines, which include PV in the generation mix with gas turbines. What input is needed and what's the general methodology? I guess we could broaden that out a little bit and say maybe not necessarily just gas turbines, but presumably Vindra is asking in terms of solar PV as one asset among many, really, I guess, within the mix.
Okay, so for this one, for what PV design generally does is forecasting the energy for PV models mainly, but what we try to do, we also use the option of batteries. We have the best system. So what you can do, you can study first your PV design here. You can your PV project here. You can create your battery area, but also apart from creating the battery area, when you generate your design, let me show you. We can take the example of this first design that have been generated. We have a list of documents, which is one of the most valuable output of our software. We have more than 400 pages of documentation here. And you can also, as an input, enter the years of simulation so that you can have the energy yield results. And based on the values that you have, you can have an idea of, for example, if you have clipping in your solar plant, the surplus of energy generated, and you can, in a way, have a specific value for your additional or auxiliary additional side project like gas turbines or other project that can be connected to PV installation. But here, from the documentation, you can have already an overview of these values. Just to mention, in the energy section, you can also introduce if you have another losses for your plants. So this also can be interesting for you if you are connecting other project to your PV installation.
Great. Okay. And you know what, Fetin, that kind of sort of answers one of the next questions I was thinking to ask. So if that's kind of already been covered, then by all means we can skip that on, and perhaps the Rated Power can follow up the conversation. So Giorgio from the audience was asking if you can use PV design to evaluate the economics of hybrid PV and battery energy storage system plants. I mean, essentially, I guess the short answer from what you just told us is yes. But I mean, are there any sort of like interesting, things or like specific considerations that folks might want to take away with them from today when it comes to that aspect of plant design?
So basically, for the financial part, for the best system, it's not included in the financial analysis here in our capex sheet and for the bill of quantity that we generate. So we give you the quantity, but for the financial, the best system is still not introduced as a financial analysis that you can study in this software for now. So also, I just need to mention that our software is always evolving, and we are each time doing new releases, new option. As you can see, this new interface is a new option that we have released. We are working on other projects, like, for example, DC coupled batteries. We try also to have, for the customers, we have the customer roles to have more privacy per project. Also, we launched the default equipment. So in case that some companies are working with the same default equipment, so to gain time and not waste time, you can select your specific equipment and use it in all the designs that are being studied. So we also have the improvements based on the feedback of our users. So our customer relationship with our customers and our team is really important for the sake of improvements of the different parameters and different options that we have in PV design.
Okay, great. And I mean, I guess, at the end of the day, battery storage, the economic, or let's say market operation of battery storage is, it's completely different in so many cases to solar. It's just a whole different thing, really, isn't it? And it just comes with its own complexities of calculations that I think there is more than enough to think about with with what you have here with the PV design software. In my opinion, anyway, my humble opinion, I guess. So there's a couple of questions about, and I appreciate in the UK, terrain. There's not a lot of mountains in the UK. There's a little bit in Wales, I guess. Wales is a little bit hilly, but certainly worldwide, it's a growing topic in terms of designing PV systems on terrain. So there's a couple of questions on this. So forgive me that it's a bit long to ask these questions, but Joe asks if there is support for 3D topography, for example, row to row spacing due to elevation changes. And if I may just continue, I believe this is related. Marco is asking if the terrain layer is uploaded from Google Maps, or can you upload your own level curves from a DWG file? So a couple of questions on topography. I'm sorry to throw them kind of both together at you at once, but yeah, if you wouldn't mind taking us through some of that.
Yeah, no worries. It's two questions that can be answered in the same part, so it should be mixed together. I'm going to show you all the topography part that we have in PV design. So I'm going to share again my screen if it doesn't have. Okay. So first of all, for now, we are considering for the energy model, we are considering the terrain as a 2D model, but hopefully next year we are working on bigger project to introduce the 3D model. But what we have now for the topography, so first, as I mentioned earlier, when you create your project, based on the location, PV Design give you the source Google Earth here. So when you click on show details, you can see the all the different elevation that you can see here with percentages. You can also see the details of your topography, the east-west slopes, and the north-south slopes. You can also from here download your elevation, download the slopes in different formats, PDF, CAD, and KML. But apart also from that, to answer the second question about uploading the CAD contour lines, for now, we are accepting CSV, XYZ, or TXT format, but also as a support for our customer, we have our knowledge base articles here that you can directly access. And there is one article that can help the user to convert the CAD file and shape file into the CSV file here to be accepted. And also as a customer success, we help you into converting this file. And in addition to it, we are now working on a new feature to allow our users to have shape files accepted as a format here for the topography. So this is the second question. Regarding to the first question, let's go to the topography section here. So first I need to clear these details here. And in the topography, you have the option to discard or install some structures applying earthwork on it. So it takes into account the topography file that you are using. So it is an analysis of that specific file in case that you want to study slope limitation for the north-south. I'm just going to show you an example. You can here enter the percentages of your limits. You can run the design here, and you will see your single design will be already, you can see results directly here. So the structures that will have slopes surpassing the 5% and between the 5 and 7% will be in orange blocks and identified here. You can click on it to see the details, the cut and fill volume for your earthwork, because it will be installed applying earthwork on it. But also if you have the exceeding of the 7%, it will be in blue. And when you click on it, I'm sorry, you will have the percentage of exceedance. And in case that you want to push further this analysis and you want to remove these structures from your final layout, you can enable this option, run again your design, and it will be in green or light blue. And in the overview here, you will see that the structures are removed from your layout. So just to compare both of this one, in this one, you can see if you don't enable this option, you will have these structures, but at least you have the information of removing the structures. And from here, you can see the analysis has been done. So it is the same workaround for the terrain undulation based on the pile length of your structures.
That's awesome. Sorry, I was getting a little bit hypnotized by how many different kind of parameters you can go through. And yeah, I mean, I'm going to say something really, really stupid here, and I apologize for this in advance, but you guys should maybe think about creating like a mobile game version of this for like, so engineers can show their kids and get them involved. I think it would be such a nice way to get people involved in the industry. But anyway, I'm sorry, I'm just talking too much now. But we've answered quite a few questions, folks. In the audience, I appreciate so much that you've got more questions coming in. There's a lot you want to know about this. So unfortunately, we are going to have to call time there for today. As I mentioned before, Rated Power will be more than happy to follow up with you on, getting those questions answered, getting into those technical discussions about the features and all that. And I want to thank Rated Power as well for describing not only the software, and also to you, Carlos from Bute Energy, not only the software and your own work, but really giving our audience an idea of what the important things are, what they should be looking for, and really showcasing where the solar PV industry is getting to now. And it's a very exciting place. So I want to thank all our speakers very much for that. And I want to thank, obviously, most of all, our audience for listening and hopefully learning. And just a little personal note from me, thank you so much to all of you involved in this fantastic industry. We're all doing great work, and yeah, may it continue and grow and grow. And with that, I guess that's probably enough from me. And thank you very much from myself, and of course, thank you from all of our speakers today. Thank you, guys.
Thank you very much.
Thank you,
Thank you.
everyone.
Excellent. Thank you. Bye bye.